All right, I have to take this. It's always a bit too much to the bottom for me. Welcome everybody to the last talk in this session. It should be. Oh well, wait a second. That's not. It should be. Actually, you should see my PhD student here, but he got sick. So that means for me now I have to just jump in and try to make the best out of it. I'm responsible for it. That's the last name. I'm Marc, Erich, Latoschik. I have the chair for HCI at the University of Würzburg. The good thing is, so if I don't know any of the answers to some of your questions, I can always say like it's him. You know, I don't know. It's his fault. Well, I try my best still not to mess this up too much. So what we're talking about. You might know multiple sclerosis, which is a disease of the central nervous system, and which basically impairs gait ability. And gait ability is very, very important for feeling, let's say, competent in your world, that you can move around. So losing your gait ability is a huge deficit if it happens to you. And it is known that usually you do training, and what you do is, if you lose your gait ability, you walk. And the best way to walk is maybe outside, but sometimes you'll not be able to do this anymore. So you need some kind of security measures. And there are treadmills and similar things like walking robots come in, because you can be secured in them and you can still do your exercises, which is good. And it has been shown in so many studies that it does work. So if you're losing your gait and if you're losing your mobility, it's good to do the training to at least try to maybe slow it down. You can't reverse it, that's the bad thing about it, but you might want to slow it down, and that's even good enough for that one. Well, so that's the good part. The bad part is, if you're not intrinsically motivated to do this, exercise is not a thing that comes in very easy to you. I mean, some are, and they might be intrinsically motivated, but you can see many users are not. And telling them now you have to walk every day an hour or something, there's a problem with the motivation. It's a monotone exercise, specifically on a treadmill. And if you don't have the right environment where you place the treadmill, it can be even worse. I've seen these things in rehabilitation clinics, and they are done, well, basically placed in the cellar in front of a concrete wall. Here, happy training, that's great. And then an hour every day, you already feel very sick and sad. That's not a good idea. So, well, it has been done in virtual reality, in both, in immersive virtual reality as well as in, let's say, semi-immersive virtual reality using large screen displays. So there is already ample literature that has been done and has been researched, and it always shows that it actually works out well. So from this point, there is no novelty in saying like we're doing this gait rehabilitation in virtual reality, because this has been done many times. But so here's two examples for the previous work. That most of them concentrate on something that we call the competence. So saying like competence as the need to master something which is a hard task for you. They try this with gamification, for example, that you get little extra bonuses if you reach a mile, walking a mile or something else. So it's like a reward system, and you try to get to the next reward, and this is why you go on and go on and go on. Also turns out that this is well known from gamification. This is one of maybe the easiest way to gamify any application, doing these reward systems. And the bad thing about it is it tends to wear out. So its effectiveness is good in the beginning, but well, it decreases slowly and well never reaches the 0 point, but it's maybe not the only thing how you could do this. And there's work by Peruzzi et al. And Calabro. I just picked out 2 in the paper. You find, I think, 8, 9, 10 or 11 different applications that have tried to do this. Well, so let's see if we have other chances to do this motivation. And we looked into the self-determination theory by Ryan and Deci, and there is competence is just one of the important aspects and important factors here. Others are autonomy and relatedness. And these mean basically autonomy, the need for decision freedom to fulfill activities which are meaningful and in harmony with your own goals. And relatedness, the need to feel belongingness and connectedness with others. That's the important thing here. And that hasn't been researched in the past. There are 2 more aspects at least if you refer to the self-determination theory, that you could explore to maybe increase motivation in these gait rehabilitation tasks. And this is what we did with this system. So our research goals and the evaluation criteria is we want to motivate patients to do this daily routine, basically. This has been evaluated, but not evaluated in a clinical setup. We're doing this with colleagues from the clinics of psychology, but before we really go into the field, we always have this separation into first, we have to make sure that our systems from the VR aspect and from the, let's say, HCI aspect do not do harm to the users, including stuff like cyber sickness. Specifically, if you go to patients, you have to make sure that you're not inducing even worse things than you really want to help with. So it's very important to have this ecological validity first up front. Make sure your system with healthy patients does what it should and not induce any unwanted effects here. We're doing this by checking for well-being, workload, and for motivation. So our contribution here is instead of only looking at competence as one of the motivational factors, we look at autonomy and relatedness. And you can see a little picture on the right side. This is a view on this artificial world where the patients do their working exercises in. And of course, we copied the same thing for the competence. We have included a gamified reward system, something like stars that you get every so-and-so minutes, and let's say every 100 meters you get another star. But we also wanted to include autonomy and relatedness. And for the autonomy and relatedness, first of all, we thought we need a storyline. Just walking without a story, where should the motivation come from? It's just the walking. We need a secondary task to fulfill here. And we also wanted to have the relatedness. And for the relatedness, we brought in, some of you might know that we are working on avatars. This is a very specific avatar. We built in a small dog which goes walks with you, and it tries to relate to you, and it has a nice story to tell, which I'm going to tell you in a minute a bit more about. So then we ran an experimental user study, and we could derive 3 design choices, basically saying that this was actually a good idea to do. So here's the storyline, the introduction. So this little dog in the introduction phase, it talks to you. It says, "Oh, hey, hi, my name is Max, and this is my home. Unfortunately, a storm destroyed it." And then he tells you the story that if you explore the world with him, and you can see that the world on the left side is just gray and it's just empty. So we built in a procedural system that creates a lively world around you once you gain more and more into the world. So this is the goal, to build up the world again. Once you're walking, you see that the world, it will become green, trees will grow, he will be happy, he will give commands to you like, "Oh, look, and now my friends, the rabbits are here." So it's trying to get this relatedness and this social interaction with you in a way. So that's the introduction phase, as you can see, and then you walk forward. And then you start walking on the treadmill. You can look down, you see your feet. You can see the colors coming in. Sorry for the noise and the sound. I think there's something. I'm already over the limit here a little bit. So we evaluated this with healthy patients, basically with 73 patients. And what we did is it's a within-subject test where each subject had to do both the non-VR version and the VR version for 7.5 minutes. That was randomized, of course. And then we took a kind of many measures. This is, you can see from the paper, but here are a few of the measures we are testing for. Simulated sickness, quite important. Some of the other ones you might as well know, they have to do with intrinsic motivation, for example. And the last one specifically has been designed to evaluate the usability of cyber rehabilitation systems, the USEC, which is quite new, I think from 2017, so it was a good one to see what's going on here with the system as a whole. So again, this is a recapitulation of the goals and the evaluation we wanted to do, well-being, workload, and motivation, and now right into a few of the results. There are many results. Please, I have to refer you to the paper. It's just too many of those. I picked, of course, the ones where the chance that they were, by just randomness, are very unlikely. I wanted to say significant, but this is just the other way to say, as I just learned from Ed Swarm during the the nice workshop that we had. As you can see, the scores for the USEC as a whole says it's, well, highly significant here. The same thing for the attractiveness. The SSQ score, something that I'd like to debate with you, it went down after using the system. So after we had the VR exposure, it went down. And that's also kind of interesting, but we have an explanation for that one. The state gait, state anxiety, it went down, pressure is lower, the frustration is lower. So most of the things are looking pretty good. We use the NADA TLX to see how the workload is doing here, like mental demand, physical demand, temporal demand, performance, effort, and frustration. As you can see, a lot of interesting results. Most of them say that the VR condition worked out better than the non-VR condition that we had. The IMI, the intrinsic motivation inventory, of course, that's one of the most important one because we wanted to increase the motivation, right? And it turns out that it's really a strong effect that we have here. And so we could say that actually with the three different aspects about increasing motivation, it really at least reflects here on these scores and tells us that it is effective as we wanted it to have. So up to the discussion, we wanted to have these competence, autonomy, and relatedness, and we had the evaluation criteria, well-being, workload, and motivation. As for our results that we had, we can confirm that the approach that we have taken basically fulfills all the requirements that we had. So now we have a system that with healthy non-patients, with healthy people, does as we expected it should do. The design implications, well, virtual reality works, yes, for gait rehabilitation. That's not new. That's one that is just confirmed from the work that we had before. Gamification, yes, that is also a good idea, but again, that's a confirmation of known things. But confirmation also is an important thing in our science. The last thing, the relatedness and the autonomy, that's something which is new and I think brings in another interesting step and does design criteria for future gait rehabilitation systems. So future work, well, we want to do this now with real patients, of course. We want to include some of our avatar embodiment stuff here. At the moment, the embodiment is just the feet that you can see, your own feet, but we have these photorealistic avatars that we want to include. We want to have different tasks that we want to solve here, not just this one walking and following task. And then we want to have different environments because they can also get boring if we bring it to the field and somebody works on it maybe a year or two. So there's a call for longitudinal studies, of course, like always in clinical setups. Thank you very much. So I hope I'm in time. All right, okay, questions?
Hi, Wendy Powell from Tilburg University. Really interesting talk and really interesting work. I'm curious because it looks to me, and maybe I've misunderstood, that your control comparison was a non-VR condition.
Yes.
And I was really interested at the beginning of your talk because you were talking about what I agree are some of the flaws with some of the environments we already use, the non-gamified, the ones that can get, or the ones that can get very boring. Have you done a study that compares a traditional VR walking rehabilitation system with this one where you've got your inbuilt narrative and the kind of the intrinsic motivators, the relatedness? Because that I would be really interested to see.
No, not yet. Not yet.
Is that something you're planning?
Yeah, sure. We have a few PhD projects at the moment on Gait rehabilitation, and that's definitely on our schedule. We just didn't have any time to do it right now.
Sure, I know, that's fine.
Yeah.
Because obviously there's a lot more effort to put these these much more complex environments in, and I'd be really interested to see the change in effect.
What we also see is here something that people know from VR, and this is the content that really is important here. In game design, for example, that's pretty much common knowledge. It's a content, not maybe the presentation of the whole stuff. And that's something where I think academia struggles many times. We usually don't have designers, and we don't have the time to put a lot of effort into content. This is precisely why we here went to a procedural generation task. We said, like, okay, but we can do the algorithms to do it, but we don't have the time to do all the design. But if you would, of course, you're right.
Yeah.
I mean, that's...
I should keep an eye for those results then. Thank you.
Okay.
Hi.
Hi.
I am Luciana Nedel from the Federal University of Rio Grande do Sul in Brazil. Congratulations for your work. What's your impression about the people in the treadmill without seeing the treadmill? Because with real patients trying to recuperate for walking.
Thank you for the question. This is why we were watching for the anxiety also. We were measuring anxiety to see, that was actually one of the things we thought, like, that could be a problem. So you're on the treadmill, something is walking below you, and you basically don't see the physical environment anymore, so it might make you just scared. Well, at least from the results we had with the healthy people, it turned out that the anxiety went away, but it was very important to have a very accurate match between your walking speed and your optical flow. So we went a long way to have the synchronization between the walking speed that you have and the speed you had in the virtual environment to be in synchrony. So to not have a conflict here, like you walk faster, but it's a slower movement of the word or something in this direction, because that, I guess, would certainly be a really detrimental factor, honestly. But not in this study so far, but this is something where I would say once you do these cyber-physical systems where you have a connection between virtual reality and some kind of actuator that then also moves people around, you really have to be careful that you don't have a mismatch there between what you induce on the motor level and what you show on, for example, the visual stimulus. It's very important. It didn't happen here, but we took very much care that it won't.
Okay, thank you.